Nick Bostrom's thoughts, and now I don't know what to think. So can you tell the people a little bit about this program reality idea?
Yeah, sure, absolutely. And people are probably most familiar with it through some of the movies from Hollywood, maybe some science fiction writing, Philip K. Dick and other people who have explored these kinds of ideas over the years. And that's cool because they generally give some sort of description of it, or a reason for it to be. In the Matrix, for example, there was a sinister aspect to what was behind the Matrix.
Yes.
Other people may say that it isn't that way, that it could be just a simulation that we've put together in the future and we're just running. I think that's more Bostrom's idea. But it actually, it goes back pretty far. Conrad Zuse, I think, was the first person to postulate the idea, and that was in '69, I believe, that our world could be digital. And from there, you can go in a bunch of different directions. You can say, well, it could be digital, but there could be nothing behind it. Or you could say, well, it could be digital, but there's some programmatic aspect to it, and therefore there was a programmer. Or it could be that it's not an entity per se that we think of an entity, but it was more of a system that evolved and generated this reality, but in a digital form. So all these things kind of fit into the general field of digital philosophy or digital physics, if you will, and we can explore the pros and cons of a lot of the different ideas.
Yeah, the thing I thought was most interesting that I'd heard you say in the past is it's very likely that at some point we'll be able to simulate reality. So isn't it also likely that we've already been there, that we're already there now?
Yeah, exactly. And that's Nick Bostrom's sort of philosophical, logical argument, and it's really hard to find fault with it. He's saying that given where we think we are, we're pursuing these kinds of simulations now. We do it with, massively multiplayer online role-playing games, and we do it with, virtual reality, and it gets more and more accurate all the time. And that, we follow Moore's law with the, escalating speed of computers and the escalating resolution of our screens and things like that. At some point, we won't be able to tell the difference between reality and a simulation. We're there now in terms of what we can hear. We could put some unobtrusive headphones on and not be able to tell the difference between a surf or really being down, at the beach and listening to the waves. And from a visual perspective, if you're able to cover your full field of vision, we can generate that kind of resolution that is equivalent to the visual acuity of the eye today. So we're really close, and
Right.
The only thing that kind of remains to be done is a scenario or a the richness of a reality, and something about our memories. Because if we were to play a simulation, put on a headset, and execute a simulation, we know because we've got the memories that we existed before we started the simulation, and that this is just a simulation. So that brings into question about the idea of how accurate are the memories, how much can we believe in the memories that we think we have. And honestly, there's a tremendous amount of research in brain-computer interface that's going on where memories are being erased in mice. They will teach a mouse how to do something, erase the memory, re-inject the memory, and show that they can actually inject false memories into mice and rats in the laboratory. So if they're doing that now, and again, we follow the logical progression of science and technology, there is going to be some day where we can suspend our memory, inject a new kind of, set of memory artifacts, if you will, run a simulation, and then restore our old memory again. So Bostrom says he refers to that as the concept of post-humanism. So when you get to a point where you can generate your own sort of fantasy reality, if you will. And, that may be 20 or 30 years away. So his argument goes like this. If that's possible, and we know that it's possible, there's only one of three things that can happen. Either we never get there, but because in the next 30 years we blow ourselves up as a society, or we never get there because we make a conscious decision not to get there. And that one, I tend to disregard that one because I think, when have we ever stared an interesting technology in the face and said, not gonna pursue that.
Agreed.
Right?
I totally agree.
And then the third one is we do get there, and we generate millions and millions of simulations, and so then if that's the case, then the odds that we're in the 30 years before that time versus one of the millions that gets generated is very small. So if you think through his logic, if you're a pessimist, you'll believe that we're going to blow ourselves up in the next 30 years. If you're an optimist, you would have to believe that we're actually in a simulation.
When you take that a step further, we could be just stuck in an infinite loop of digital realities within digital realities where we learn more and more and more and create another one and create another one.
And I think that's actually really an insightful thought because, it's sort of like a fractal. If you're familiar with the pictures that show these fractal images, and the more you zoom in on them, you see the same thing. And there are a number of scientists and physicists and so forth, Tom Campbell comes to mind, who believe that our reality is a fractal. And if you look at it at different scales, you see the same thing, the same kind of structures, not just physical structures, but the way things tend to work. Mm-hmm. And this whole idea of, we could be in a simulation now, and in our simulation we're creating simulations, and in that simulation we're creating a virtual reality game, and someday that'll be a simulation. You know what I mean? That whole aspect of things is also fractal. So it all kind of fits.
Yeah, I mean, on the subject of fractals, I've seen those pictures where people put on one side like a cell in the human body, and on the other side a galaxy, and they look so similar. Yep. It's that same Zen philosophy point of, everything is part of the whole.
Isn't it? Yep.
Yeah.
I really like those, and it's striking when you look at some of these cosmological maps of the known universe and all these little tendrils and things like that are in the maps, and then you take a look at a cell or something, and you see the same structures. And that's not to say that the cell is a universe for some other entities. That could be a little bit of a crazy idea, or maybe not. But the more to the point is that there's some organizing principle to our reality that makes things grouped together in large scales the way it makes things grouped together in small scales, the way things communicate in large scales, that is similar to the way they communicate in small scales, the way they form structures and so forth. And that organizing principle, what is that? We haven't discovered that from a scientific standpoint. Some physicists might point to things like string theory or grand unified field theory or something like that, but those are really things that are meant to describe physical matter particles, and not really to describe these mega structures of our reality. So just the fact that they repeat at different scales is interesting by itself, and kind of implies that there's some organizing force at work here.
I mean, other examples of that is the Fibonacci sequence and the phi ratio. That idea that there's just some type of code to it all. And I spend a lot of my time in the conspiracy world, but that kind of ties in because that is apparently the type of knowledge that secret societies have held on to for generations and generations and generations. And the ultimate could be that they're like, oh, yeah, well, this is the program that we've created, and, we're living on top of it here, and we could exit at any point, but they don't have the ability to do that. Wouldn't that be a trip?
Well, it is really interesting. I agree with you. If you go back and look at some of the ancient texts, the Sumerian texts, or some of the hieroglyphs that you see at various ancient sites and things, and try to figure out what they're telling us. We tend, in the past, we've had this sort of arrogant assumption that, they were just inferior to where we are now, so they couldn't have been on to anything significant, But it only seems to happen that the more we learn about our past, the more surprised we are at how rich it was and how philosophically accurate it was, or something like that. And it's the same way with the way we treat animals. The more we investigate how animals communicate and how they behave, the more surprised we are that, oh my gosh, they have ecosystems and social systems just like we do. Why is it that we don't assume that in the first place? Why do we have to assume that humans in the past and other species of animals are necessarily inferior to us? And why do we have to assume that we humans have the access to all that there is, or all that there could be to know? I think it's a very arrogant point of view.
Definitely. Yeah, I mean, the universe is a weird place. We seem to figure out more about it all the time. One point that you've discussed in the past that I thought was really interesting is the scientific trend, this pattern that seems to occur where every new leap in understanding yields a larger ratio between matter and empty space. We kind of discover that the universe is more empty than it is full. Walk us through that trend a little bit, and where do you see that trend going or ending, if it ever ends?
Oh, sure. That one's really fascinating to me, and it's actually a pattern that I just kind of noticed just a few months ago, and I wrote a blog on it. We know that over the years we've been peering deeper and deeper into the atom as we get more and more powerful instruments like the Linear Hadron Collider and things like that, higher energy instruments that we can use to break apart things and look deeper in. Mm-hmm. So, but if you look at the kind of history, you actually see a pattern, you see a trend here, which was a revelation to me. So let's go back to the ancient Greeks. They thought that everything was made of these little hard billiard ball type objects, call them atoms. And let's take gold, for example, that gold was, gold bar consisted of a bunch of those little billiard ball type indivisible things called atoms that were just packed together. Well, if you pack together kind of spherical things, there's going to be some empty space in between them as well, and the empty space is something like 28% of the total space it takes up. So this, we didn't really advance from this theory until, well into the 1800s. John Dalton revised the theory in that time, and then there were some, changes to the theory of atoms. But the real breakthrough came in the early 1900s with Ernest Rutherford's experiment that showed that there was a nucleus to the atom, and they were able to determine what the cross-section of that nucleus was, roughly how big that thing was. And found out that, wow, not only is not our gold bar isn't really just like 80% stuff, and that's the word that I tend to use. Mm-hmm. It's more like 1 times 10 to the minus 15th stuff. So 1 part in, I guess that would be maybe 1,000 trillion stuff. So it's so much empty space that it's almost inconceivable. But it didn't end there. In the 60s, with quark theory, they realized that the nucleus, these protons and neutrons, were actually composed of something else. They're composed of quarks, and those quarks were much, much smaller, and that most of a proton was empty space. So now and they've been able to do some estimates on cross sections of quarks. Now they're saying that our gold bar is 1 part in 10 to the 28th, stuff, and everything else is empty space. And then the string theorists came around in the 80s and 90s and said, well, even quarks are made of something else. They're made of these little vibrating bits of string that vibrate at different frequencies for different particles. And the width of this string is what's known as the Planck length. And the Planck length is something like 10 to the minus 35 meters. It's the limit of quantum mechanics. It's the limit beyond which you can't probe any deeper. And that's what they say the width of the string is. So if you do that calculation, you're up to something like 1 part in 10 to the 52. and 10 to the, first of all, 10 to the 1 part in 10 to the 30th is equivalent to a grain of sand is to the size of the Earth. So 1 part in 10 to the 52 is like a grain of sand, in the solar system, or maybe the galaxy or something. I'm not even sure. I haven't done that
Jeez.
calculation, but it's ridiculously empty. And I start thinking, well, what's the point of having stuff anyway? The trend is that every 60 years or so, we lose about 15 orders of magnitude of density of our stuff in the best theories of science. So if we keep going in that direction, we're heading toward the ultimate, which is there really is no stuff. It's really just data, which to me it's kind of one of these big trends that I see happening in scientific theory, and as we kind of peel the onion of what makes all of this tick, of what the rules are in science, we peel it back further and further, we find that there's less and less stuff, and probably at the end of the day there's none. All it is data and rules. And if you think about it, if the string theorists are right, they say that a particle is only defined by one number, and that number is the frequency that string is vibrating at. Well, if you can define a particle by one number, what do you need the string for anyway? You just have the number.
Mm-hmm.
You see what I'm saying? So and people will argue, well, I feel stuff. I put my hand on the table and I feel the hardness of it. And well, actually you don't. What you're experiencing is the
charge,
electromagnetic charge, electromagnetic field charge of the atoms in your fingertips repelling against the electromagnetic field charge in the atoms of the table. And what you're seeing is reflected light, off of that. And when you really think about this very deeply, it's okay to say that everything is data and everything is data and rules. And so when I punch a wall, the rule is that I'm going to get a sensation that is a result of the very deep rules of electromagnetic interaction and how they translate to pressure and things like that get converted into bits in my nervous system and get processed by my mind. So when you really think through this stuff, there's no evidence for any stuff at all, and there's really a lot of evidence that we're heading toward a trend of recognizing that everything is just made of data and rules. So that's more evidence for a digital world or a programmed world.
Yeah, man, it's really hard to wrap my head around it. And another component to this is the idea of the conscious observer. I mean, there's been some experiments that seem to suggest that waves stay waves until they have a conscious observer, and then they become particles, or they make some type of choice. Again, it's pretty over my head, but there are those studies out there. What do you make of that? What role do you think human consciousness plays?
Yeah, I think that's really the way is a great question. I think that is kind of the key fundamental aspect of what is under investigation today in any field of science. It's the key thing that is showing that our reality isn't what we think it is. Everything else that we're studying is just kind of peeling back the onion, but this observer effect that you're talking about and some of the aspects of quantum mechanics, entanglement and things like that are showing that deep, deep down our reality is very, very different from the mechanistic type of approach that most scientists have believed over the years. And in this experiment you're talking about, this double slit experiment, has been replicated countless times. And the way that it works is that every time human consciousness gets involved in observing the result of the experiment sort of locks into a particular result. So, the way this experiment works is you have a little detector on backside of effectively like a cardboard that has slits in it, and you're shooting particles through that, and the detector detects whether whether the particle went through one slit or another. And if you have that detector there and you're looking at the results of the detector so that you, as a human, know where each particle is going through, then you no longer get that waveform. But if you turn the detector off, or if you let the detector on but somehow are not paying attention to the detector, or having a conscious observation, there will be a waveform on the screen. So they've tried to tease out all the possible explanations of this weird effect. Like they used to think, well, maybe it has to do with the fact that the detector is stealing away a little bit of energy from these particles or something, and that was disproven not too long ago in Tel Aviv, a scientific lab there. And finally, in I think it was 2008, these physicists in Vienna determined to a ridiculous level of certainty, 80 orders of certainty, meaning the odds of this being chance were 1 in 10 to the 80th kind of thing. That reality doesn't exist at all until we observe it. So what do I make of that? I think about it from the programmatic standpoint. If I were creating a reality that is programmatic, I would do it exactly this way, and here's why. Let's say you want to create a coffee cup or something. Mm-hmm. Let's use a tree because it's bigger. That's the one that I typically use. So do you really have to define what's inside the tree? You don't. And from a programmatic standpoint, it would take an awful lot of memory resources and computational resources to calculate the structure of things that nobody's ever going to look at. So you don't bother doing that. If I were creating this kind of simulation program, all I would create is what people can experience. So now as soon as somebody cuts into the tree, there has to be something that generates the construct of the tree. Now, if you take a piece out of the middle of that tree and put it under a microscope, now there has to be something that generates, something at a deeper level. Mm-hmm. But the rest of the stuff on the tree, we don't have to care about, at that level. So, the further down you go in this thinking, you realize that once you get down to the particle level, now I'm looking at a number of particles, and they have to have some rules. They have to be behaving in a certain way because I am measuring them, I'm observing them. So now we've made those particles lock into a particular state. That's exactly what happens in quantum mechanics. That's called decoherence, and that's why these effects occur. Everything else is probabilities until we force the program to generate reality. In our minds. Then you get things locked in. That's why entanglement occurs. You can take particles and move them light years apart from each other. Of course, they haven't been able to do that in experiments. They've done miles and 20 miles or something like that. But they've proven that these things they act as one particle. They don't act as two particles anymore. And the reason I would say is because they're following rules of the program in lockstep. The program is saying, well, it's like a little state machine, if you will. The program is saying, okay, when this particle has the spin up, this particle over here has spin down. And every time it clocks through another calculation of reality, it sets those two particles to be equivalent. So for all intents and purposes, those particles are one and the same. It's like two pixels on the computer screen that you look at. Every clock cycle, those 2 pixels are being repainted. So the underlying construct that drives those pixels is something that's very consistent. You could move those pixels, far apart from each other, and still every clock cycle they'll get repainted. It doesn't make any difference how far apart they are because they're all driven by the same underlying mechanism. So that to me is a perfect explanation for every quantum mechanics anomaly, and I have on my site actually the kind of like pseudocode, little bits of pseudo software, if you will, that explains the observer effect and entanglement and non-locality and all these things that the scientists are kind of beating their head against the wall trying to figure out. It's perfectly logical if you think about it from a simulation standpoint.
Yeah, I mean, how funny would it be to find out that looking outward into space or down under a bigger and bigger microscope is just fruitless because it will always unravel to be something else. Like we're living in an infinite field of waves, and the further you look out, the universe will just manifest more galaxies, more stars, more, nebulas, and
Yep.
it just will never end.
Yeah, exactly. And it's interesting you mentioned that. I had a blog recently too about these, sort of another megatrend, humanity megatrend of what our perception of all that there is, and it has changed maybe 9 or 10 times over the history of humanity. There was one point in time you could imagine that there were, during a tribal era when people thought that all that existed was their tribes and the dominion that they lived in. And then along comes some other tribe from miles away and conquers them or whatever, and they realize, wow, our view of reality is much bigger than we previously thought. It's a whole level bigger, and it maybe expands now to a continent. And then at some point they realize that, wow, there are other continents on this planet, and at some point we realize there's other planets, and then we realize there's other solar systems, and so on and so on. And the interesting thing is that if you plot the dates at which we become aware that there's yet one more level of expansiveness to our worldview, if you will, they follow a perfect exponential pattern. And the last one was, again, in, say, like the 1990s, people like Max Tegmark talked about the multiverse theory and postulated all kinds of ways that there could be parallel realities and parallel universes. Well, we're actually due for another one, and there is another one, and this other one is exactly what we're talking about tonight. It goes a little bit beyond the idea that we're just in a simulation. It explores the idea that if we're in a simulation, there's something that created it, so therefore all that we can know is in the simulation, but there's something else out there that created it. And what that reality is beyond the multiverse concept, because the multiverse concept still talks about physical realities. The next level of thinking here is non-physical realities, and this is where folks like Tom Campbell and Stephen Kaufman go into sort of a bigger description of what all that there is could be. And it's interesting that if you don't think about that, you're always in kind of a bubble, and your bubble is everything that you know, and so therefore you have to explain everything that you observe by what's within your bubble. But if you can somehow understand that there's something outside of that bubble and try to infer what that is, or maybe travel to it or whatever, and I think we do travel to that when we travel consciously, then you can realize that the mechanisms that created our bubble are different, and they can explain some of the things that we see. It gives you a whole different perspective on the world that we're living in and the purpose that we have and things like that. So it's really very interesting to kind of go down that path. And it's a little bit beyond just pure simulation theory. It's what else is out there,
Well, on the subject of the bubble, of being in the program, are there any clues to suggest what could possibly be there, what we could possibly see if someone pulled the plug on that program?
Yeah, I think when people die, they get a clue. I don't know if you've followed much of the near-death experience research or, say, out-of-body experience research.
A
But
little bit.
these are cases, and it's not. This isn't pseudoscience. I mean, these are real scientific studies that have been done, over many years. That there is a consistency of reports that people have. Their behavior changes after these things, which wouldn't make sense if it was hallucinatory. There are things that they experience that then can be corroborated later on, like past life regressions, perhaps, or telepathy or clairvoyance or something like that. Remote viewing. I mean, the Army funded remote viewing for like 20 years,
Yeah.
so it wasn't that that didn't work. I think they
Yeah.
would have killed the program if it didn't work at all.
Right.
So
20 years that they tell us about.
yeah, exactly. So anyway, these things go outside of the bubble that I referred to before, and so this is evidence. It's tricky evidence because it isn't necessarily as reproducible as a lot of scientists would like.
Mm-hmm.
But science isn't all about reproducibility. Something isn't science just because it's reproducible. There's lots of things that take, geology, for example. Scientists try to infer why a particular geological formation occurred. That formation will never occur again exactly as it was. It may have been due to a unique event, a meteor or something like that. So reproducibility isn't required for science. A sum total of a lot of anecdotal information or survey information and things like that is real science. In psychological studies, that's real science. So, yeah.
Go ahead.
Sorry, go ahead.
No, you go for it. I'm here all the time.
Yeah, no, I was going to say that these kinds of studies into what might otherwise be called paranormal, just because it doesn't fit in with the sort of materialist paradigm. These kind of studies are exploring, that next level of, quote, all that there is. And I think that's really, really interesting.
It is. It's almost like that's the beauty of the design, is that the illusion is so strong. Like we talked about the discoveries that the world that we think is made up of stuff is mostly empty. The illusion is very strong, and I think that's the kicker to it, is that these types of out-of-body experience, I kind of think out-of-body experience, near-death experiences, dreams, psychedelic trips. I mean, even the fact that we call them trips, that's like a journey. I do think that those kind of things are all related and they're all clues, but the funny thing about it, the big joke, is that you can only have that experience for yourself. So you may get a clue, a major clue about what exists outside the bubble, but you can't share it with anyone. It's like trying to explain the color green to a guy who's been blind his whole life.
Absolutely. And, this is, I thought about all of this in the sense of a sort of like a line or a spectrum of what I would call consensus reality. So when you dream, you're by yourself. You're in your own mind, and you're experiencing something, some energy, some organizational structure of an experience, right? You're experiencing that, but you're doing it maybe by yourself, and so therefore you have the freedom to make of it what you will. If you can lucid dream, you can now mold it and so forth. Mm-hmm. Now, there are studies of people who do mutual lucid dreaming, and now when that happens, the people who are mutual lucid dreaming, there's a little bit of consensus that has to happen. They have to experience the same thing in a similar way. It doesn't have to necessarily be exact, but it's more toward that consensus reality side of the spectrum and not toward the personal fantasy type of the spectrum. In our day-to-day reality, we're very much toward the consensus reality end of the spectrum, because a car drives by and it's blue and you see it and I see it, and we have to both say, hey, we saw the same thing. But so we have this consensus, and that's what makes us think that this physical reality is so, quote, real, and that the other stuff is not. It's just the consensus. but a consensus can be generated programmatically too. If you're playing a virtual reality game on the computer with a bunch of people, logged in from around the world, and everybody is shown the exact same thing, and a blue car drives by, and you say to some guy in Japan, "Hey, did you see that blue car?" And he says, "Yeah, I saw it too," because the program has presented that to both of you. Now you feel like, wow, now I can really trust what I'm seeing because everybody else is seeing the same thing. Mm-hmm. But what if that guy is shown something different, shown something because of his level of expertise or his level of knowledge or his health points or whatever it is, and this happens in games. It's an easy thing to program. Mm-hmm. Now you have a little bit less consensus. That guy sees a UFO and I don't see it, or that guy experiences the monster in a different way than I do. It's all very possible, and it explains all of our less than perfect experiences of reality when compared to what other people experience. I mean, it happens a lot of times. People will say, well, I saw one thing and somebody else saw something else. Mm-hmm. That's okay. That all fits within this paradigm.
On the subject of lucid dreaming, it's almost like lucid dreaming is the placebo effect of that plane, because it almost ties into the power of thought. Because in a dream, 9 out of 10 times you think everything is real, you think the danger is real, everything that in your waking life you look at as, wow, that was completely strange and impossible. It seems very real. But then there's these people who have lucid dreams where they just completely realize it isn't and completely take control of it. And then, in our waking life we have this thing, the placebo effect, which is a very similar thing, just nerfed. It's very nerfed. But, if there's plenty of cases of people who get better because they believe that they were given medicine when in reality they were given sugar pills or whatever. It's very strange. I mean, how far do you think you could follow that thread? How much do you think you could manifest your own reality, if at all?
Yeah, well, so I think this is very much related to the observer effect that we talked about before. Mm-hmm. When our consciousness interacts with matter, we create a reality. In the quantum mechanical terms, we collapse that wave function. We collapse that probability into an actual place and time, because of that the program has to do that. So the same thing happens with our future. Our future is all probabilities, isn't it? And if this physical reality is really just virtual, it's just data that we're consciously processing, then we have more control for things that are further in the future than we do for things that are going to happen in 1 second. Because remember, the stuff that's going to happen in 1 second has to fit with everybody else's consensus. So you got a guy sitting next to you, and the two of you are watching a baseball game, and one of you tries to consciously make the player hit a home run, and the other one tries to consciously make the player strike out. You can't both win that. So only one of those things is going to happen. Whereas, further out in the future, there isn't so much, you're not so close to a consensus or a locked-in thing. You can influence things further out into the future. I mean, theoretically, that all makes kind of sense to me. The program is, if you believe in this kind of construct, and I always say that I'm not, 100% sure of it, but the evidence, my book is about evidence. It's not about, I know this to be true or anything. Mm-hmm. But if you kind of think about this, this power of positive thinking kind of aspect to it, then, really there's no reason why you can't control your destiny to some extent, interact with people through means other than our normal communication, and all these kind of things that could be possible in a program. We don't necessarily know what the rules are of this simulation. We push the boundaries of them with studies like remote viewing and experiences like near-death experiences and so forth. And through those studies, we're starting to learn a little bit about what we can do and what we can't do. The placebo effect is showing us that our minds, which are not in our brains, our minds are probably somewhere else, really can influence and change our outcomes.
Well, it's funny because the idea of manifesting the reality, I would love for it to be true, but I have so much doubt. And in the conspiracy world, a lot of people believe that the elite's main objective through media manipulation and news manipulation is to create doubt and to create fear, because maybe the manifesting of reality is completely possible if you believe it, but yet we're conditioned to have so much doubt in ourselves that no one ever really can commit 100% to the premise because they've just gone through decades of being told that that's bullshit.
Yeah, I think that's really insightful. I think that's a good way of looking at it. That if we were fully free to, and this is one of Tom Campbell's arguments, if we were fully free to make of our reality what we want to make of it, we wouldn't learn as much as we do. And in his philosophy, and this is something that kind of resonates with me. And to be honest, from a standpoint of digital philosophy and digital physics, there's a lot of different views and a lot of different people out there who have been thinking about this stuff. It's important that we not be able to fully influence everything. If everybody was able to influence whatever that they wanted, they wouldn't learn as much. So, some of the constraints that we have in terms of how we can communicate with others, what we can know about what's outside of the bubble, what we can know about a past life if we had them, those kind of constraints are important so that we can learn faster and add to the overall evolution of ourselves.
Right.
If you were to plot the amount of knowledge or wisdom that you attain, it probably is very steep early in your life, but as you get older, it flattens out, and you don't gain that much more. So the system, if you will, in order to optimize how much consciousness quality there is, it would have to encourage entities to live early in this cycle. So perhaps that's why there's death. Perhaps that's why we reincarnate. This is all something that kind of fits in this theory.
Yeah, man, it's super fascinating. It kind of has a lot of parallels to the Zen philosophy that we just are the universe. The main difference just being, are we the creator, are we the programmer, or is there some external programmer? Because I guess the big question is, how does the program decide to put rings on the inside of a tree trunk when you cut it open? Does it come from our own subconscious, what we would expect to see, we see, or is the program using some other algorithm to create that stuff? That's
right.
kind of kind of one of the fundamental questions.
Yeah, it's a good question, and I think kind of using sort of a collection of ideas from shamanistic thinking, Zen philosophy, modern digital philosophy. The program, if you want to call it that, or the system, has evolved, and it's evolved to learn to do what is best. So if the best thing is for it to be really efficient and generate those, the content of the rings of the trees, then that's what it's going to evolve to. I mean, if you think about sort of the theory of natural selection, Darwin's theory follows a similar type of approach. The sheep that have the thicker wool in the high cold altitudes tend to pass on their genes more, whereas the others don't. So an artificial intelligence or a system of consciousness that is evolving is going to do different experiments, and the experiments that have positive or profitable results will get encouraged, and the ones that won't, and the thing will eventually evolve to be efficient. So this actually, I read a book recently, a Zen book, and I read a passage in it, and I thought, oh my gosh, this sounds exactly like digital philosophy, and it's amazing that people thought the same way as some of us who are in this field are thinking now, and we've come at it from technology and physics and all these different, fields. But it's matching, and that's really cool. It's almost telling us we're onto something.
Yeah, there definitely seems to be this meeting in the middle between psychedelic adventures, certain religions, and old Gnostic ideas, and modern science. It is a pretty interesting culmination, and it's funny because if you look at history, how opposed these different areas were, and as they all advance, they all seem to be, coming to the middle. Maybe we're getting close to something.
Yeah, and I think we are, and I think that it's important to stay open-minded, and I think that there are very close-minded individuals on both sides of that fence, and some of them are pretty loud, and it's unfortunate. Yes. Because all we're trying to do is seek the truth here, and do it without being told what we're allowed to think and what we're not allowed to think.
Right. Well, it's another curious thing, not to be too conspiratorial, but are those dogmatic voices in science, are they popular because the people who don't want us to know the truth are in charge of the media, are in charge of what we see and who gets to be the loudest voice, and they purposely put those people up there for a reason, just to keep us in the dark a little bit longer? I don't know.
Yeah, I don't know. I tend to think a little differently. I think it was Gandhi who once said, an expert is someone who knows more and more about less and less until they know everything about nothing.
Yeah.
And that's not to disparage, anyone who has gotten their PhD in a particular field, or some advanced degree, or really focuses on being an expert in a very narrow thing. But you can't be an expert in everything. So when you are an expert in a very narrow field, which tend to be scientists, people who write papers, people who do the experiments and get known for these things. When you do have that very narrow but very deep set of knowledge, if somebody comes along and pulls it out from under you, your whole reason for being, your whole reason for getting funding, that helps pay your mortgage and maintains your stature at your university or whatever, that all goes away. Mm-hmm. So I think there's a lot of fear and defense mechanism that happens when people start challenging some of these very old ideas.
Oh, I totally agree with you that is the reality, but I guess I just have more of a question of if it's just unfortunately the way it is, or if it's a result of careful planning to orchestrate that system. But another thing I wanted to ask you about was the idea of, as we look out into the universe, it manifesting itself as we look further and further and develop the ability to do so. How do you think that could apply to extraterrestrials? Do you think maybe being more open to the idea in modern times, having more of an expectation of the possibility of finding something, that it might actually bring it to fruition?
Yeah, I think there's something to that. They may be other organized conscious entities in the greater field of consciousness as we are, just different, and the rules of our interaction are different than what the rules of our interaction with ourselves are. That's sort of the way I would look at it. If we want to make more contact, probably the more that we get in touch with this, idea of how there's one global consciousness, and maybe make requests for those interactions might bring us closer.
Yeah, it's a curious thing. Maybe we're already deeply in those communications and we just don't know it.
We might be. Those might be some of what happens in the dream state too.
Yeah, totally agree. Hey, it's been great talking to you, man. Before we go, I wanted to ask you one other thing. It seems like I see new crazy scientific discoveries like every other day online, whether I understand it or not. But what are some of the more recent things to come out of the internet that you've seen that most interest you?
Well, one of them that I just saw last night was fascinating. Was a study with some experimental evidence that shows that time may come out of this whole entanglement idea. So, time itself exists within the sort of the bubble of space where things are entangled, and outside of it, time doesn't exist at all. I'm still trying to wrap my head around this, but this one, I mean, it feels to me intuitively like it may be another piece of the puzzle. It might be something that can give us some more enlightenment about the way the greater reality works.
Yeah,
that's pretty interesting.
Yeah, it's almost like an evolution of the same principle that, the reality we look at, the stuff we look at feels so solid, looks so solid, but it's mainly empty. Time feels like such a fundamental necessity, yet, if there was a way to explore it deeper, we might find that, there's more timelessness than timeness.
Exactly. Yeah, and there was also an article about some people from Arizona State. Paul Davies was one of the ones, a very well-known scientist, that the transition from inorganic to organic life was based on information and not chemistry. Well, that all fits in perfectly with the programmed reality idea as well. So a lot of cool things that people are starting to think about if they stay open-minded.
Yeah, right on, man. I mean, I think I'm not a smart man, but I'm an open-minded man. So sometimes that's better.
Well, you asked some great questions, so I'd put you on the smart side.
Oh, well, I appreciate your kindness, but well, man, it has been a blast talking to you. Even though I feel more insignificant than ever, I'm somehow still in a good mood.
I think that's okay. I do too, and I'm all right with that.
For sure. Do you want to tell the people a little bit about your book and your website before we go?
Oh, sure. Yeah, the book is called The Universe Solved. It's available on Amazon, both in a hardback form and a Kindle version. The website is theuniversesolved.com, and that's probably be doing an overhaul of that over the next year or so. Right now, it's